Tactical air warfare. Here you can see US F-4 Phantoms doing a bombing run during the Vietnam War. Now, air power actually precedes the first flight of aircraft. In 1794, French generals used balloons to direct the Battle of Fleury. In 1797, Napoleon Bonaparte used balloons for the siege of Mantua in order to guide artillery fire. In 1852, we have the Giffard airship, which became steerable in France. And these types of airships went on display in demonstration flights around Paris. In 1899, the fear of airships being used to bomb cities led to a 5-year ban placed on them during the Hague Conference. The Wright brothers managed to have the first controlled and powered flight of an aircraft on December 17, 1903 at Kitty Hawk in North Carolina. And from that followed a very rapid evolution of aircraft. Much of it driven not by the military, but by the sports community. H.G. Wells wrote his book in 1908 entitled War in the Air, in which he envisioned dirigibles flying over cities and destroying them in a war. Now, aircraft are an instrument of war, and they're limited by the physics of the medium in which they operate, which is within the atmosphere. Air power operating from the sky has access to the Earth's surface. That's its first characteristic. The second is elevation provides a broad perspective, greater potential speed and range, and three-dimensional movement. 3. Air forces can quickly concentrate their power from widely dispersed locations. 4. Air power can bypass enemy land forces and can be applied directly and simultaneously to an enemy state's military, political, economic, and social structures. We'll talk more about this in a future lecture. Number 5. Air power may be used independently or in coordination with ground forces. Here you can see a picture of a Soviet MiG-25 Foxbat interceptor, originally designed to destroy high-altitude US bombers. It later took on a role of reconnaissance because it could fly at 3 times the speed of sound and was used to fly over Israel to take pictures of the Dimona nuclear weapons facility. One of these aircraft defected to Japan during the Cold War, flown by Belenko, a Soviet pilot. And the Americans dismantled it, and they found a large part of its electronic components were illegal Soviet purchases of Texas Instrument chips. While the aircraft was of an excellent design, its engineering had a number of flaws, which was a function of bad quality control. Number 6. Because air forces cannot remain aloft, they rely on ground bases that are vulnerable to enemy attack. And so care must be taken to harden those ground bases, typically airfields and airports. Number 7. Air power is expensive in all its forms. Number 8. Air power cannot hold ground. It can only attack it. Number 9. Air power is based on rapidly changing technology that must be understood. Currently, we're looking at 6th generation stealth aircraft, and the 7th generation aircraft will likely be unmanned drones networked together with other drones or aircraft, or autonomous vehicles. Air power is still governed by the logics of the principles of war, such as selection and maintenance of the aim, concentration of force, initiative and maneuver, as well as others. This is a quote from Lieutenant General Adolphe Galland, a World War II Luftwaffe air ace. He shot down 103 aircraft. Quote, "One of the guiding principles of fighting with an air force is the assembling of weight by numbers and of a numerical concentration at decisive points." Close quote. You can see here the different generations of aircraft. The first generation during the Second World War. You've got the generation number 2, which fought over Korea. Generation 3, which was the later 1950s and the early 1970s. Here you've got Generation 4, and these are aircraft developed in the 1970s and deployed in the 1980s. Generation 4 Plus would have been extension of those airframes into the 1990s. Generation 4 Plus Plus are some of the aircraft that are currently flying today, and Generation 5 is the emergence of the new stealth aircraft. Since the first large-scale application of air power in the First World War, the essential theory of air combat has remained largely the same. There are 4 missions. The first mission is reconnaissance. This is to acquire tactical, operational, and strategic intelligence. One of the specific functions is BDA, or Battle Damage Assessment. After a target's been attacked, aircraft fly over the target to assess the level of damage to determine whether the target needs to be struck again. In this picture, you see a U.S. U-2 aircraft in flight, which is the principal way that the U.S. collected information during the Cold War. These aircraft flew over the Soviet Union, Cuba, and the aircraft were shot down in both instances. U-2 pilot Gary Powers was shot down over the Soviet Union and taken prisoner. And Anderson was shot down over Cuba and killed. And these aircraft also flew over communist China as well as a great many other countries. They fly at extremely high altitude, and they were difficult to see. Although in the case of Gary Powers and Anderson, the SA-2 surface-to-air missile did identify and shoot down the aircraft. Here you see a French Spot satellite, which is one of the first satellites to provide commercial imaging. This is a camera held out the side of an aircraft during the First World War that allowed for aerial photography and reconnaissance. This is a photograph turned into a sketch of the battlefield. This is a US SR-71A Blackbird on a tarmac and in flight. These were Mach 3 reconnaissance aircraft that flew over China and other important targets. They replaced the U-2 because they were less likely to be shot down. This is a radar image of columns of vehicles on roads detected by a J-Star, which is a U.S. reconnaissance aircraft from the 1990s with a side-looking radar. So this is one of the many varieties of reconnaissance type of services provided by the Air Force. The second mission is air superiority. Air superiority's goal is to obtain control of the airspace and by denying it to the enemy's use. This normally consists of patrols to find and destroy enemy aircraft, aircraft on standby ready to launch on air bases, and interceptors that are chasing detected enemy aircraft. The destruction of enemy ground-based sensor systems, such as radars, the destruction of enemy-based systems with surface-to-air missiles, and a variety of electronic warfare techniques and air-to-air refueling to support these missions. Here you can see a US F-14 Tomcat firing a Phoenix air-to-air missile. This is usually the first priority mission, since other missions will suffer very high losses if they encounter an enemy air force that is not destroyed. Usually it is not necessary to destroy the entire enemy air force, but just sufficiently to keep the enemy air force from interfering with friendly strike, reconnaissance, and transport missions. Although most aircraft are equipped to launch missiles that fly beyond visual range, referred to as BVR, there are only a handful of cases of enemy aircraft being shot down by BVR, mostly in the Arab-Israeli wars, largely because of the danger to friendly aircraft in high-density air environments. Here you can see a German Tornado aircraft with anti-aircraft missiles slung underneath its wing on pods. The third mission is the strike mission, essentially the bombing mission. There are two types. The first is the Close Air Support Mission, or CAS. This is the use of bombers in intimate and direct support of friendly ground forces. This requires significant training, and there's a major risk of friendly fire losses, of actually bombing friendly forces, because they operate so closely to forces on the ground. These aircraft must often fly low and fast to avoid enemy aircraft defenses and surface defenses and drop their bombs at a precise location close to friendly forces. The benefits of CAS is synergistic and follows the logic of combined arms operations. Marine close air support typically operates within 50 to 200 yards of ground forces, where the U.S. Air Force, which trains less in this mission, typically gets as close as 1,000 yards to friendly positions. The loss rates for Israeli close air support missions in 1973 were 18 per 1,000 sorties, which means it's a much more dangerous mission for aircraft than conducting interdiction, which is basically bombing targets deep in enemy territory. Both pictures here are of Apache combat aircraft. Here you can see an A-10 Thunderbolt aircraft, which flies in the U.S. Air Force. It's equipped with a GAU-8A 30mm Gatling gun, which is useful for destroying the top armor, which is normally thin, of armored vehicles. The second bombing mission is Interdiction. This is the use of aircraft against ground targets independent of friendly ground forces, typically far behind the front lines of the battlefield. These operations are often conducted not to kill enemy formations as much as to delay them so they cannot achieve a dangerous concentration of force against friendly forces. We can make a comparison of damage. A US F-15E ground attack fighter bomber can destroy 2 static armored vehicles in a single sortie, or a column of 6 moving armored vehicles, or 1 entrenched infantry section of 10 soldiers, or a platoon of 30 troops if the troops are moving in the open. A US air wing is expected to be able to hit 200 targets a day in 1991, and because of improvement in precision munitions, 700 targets a day in 2003. A U.S. air wing is approximately 50 aircraft, or 3 squadrons of 12 to 20 aircraft. In this picture you can see an F-16 aircraft, which are relatively less expensive non-stealth aircraft used to do routine bombings in less than extremely hostile environments. So this is the schema of a typical attack. You've got Black Force attacking targets in Red Force. The main attack force is at A in the center middle of the screen. You've got a diversionary attack on the southern part of the screen and the northern part of the screen. You've got EF-111As, which are electronic warfare aircraft that are jamming the enemy radar and attempting to reduce the enemy's surveillance of the incoming aircraft. You've got an EC-130 compass call aircraft, which is for surveillance, and a TR-1 aircraft. You have CAP at the top, which is combat air patrol. These are fighter aircraft that fly in a loiter position, and they will intercept large enemy aircraft that try to disrupt this airspace. You can see the EC-3A AWACS aircraft. This is an aircraft with a radar that coordinates through radio all of the air operations, and with its radar can detect enemy forces hundreds of kilometers away. And then you've got the tanker aircraft on the left side of the screen, which provide fuel to all of these different air units. Now there are a number of issues with bombing. Issue number 1. The damage inflicted by air power is often exaggerated. During the 1991 Iraq-US war, the Allied Air Force destroyed 2,000 of the 5,500 Iraqi tanks in about 6 weeks of bombing, under the best case conditions of clear skies and no cover of terrain. When the US and Allied land forces invaded Iraq and Kuwait, they destroyed about 2,000 Iraqi tanks in about 4 days of fighting. The destruction of Iraqi tanks by the army involved far more soldiers and equipment, but took far less time and probably cost the same. Here you can see a German Tornado dropping anti-tank bomblets. The bombs are small, but they're meant to destroy the very vulnerable tracks of tanks when the tanks are in motion. Paradoxically, aircraft, because of the type of ordnance they use, are better able to damage moving enemy tanks than non-moving enemy tanks. A second issue in bombing is the use of bombing against developing countries. Now, it's safe to fly at extremely high altitudes from which lasers can be used to guide laser-guided bombs against ground targets when operating against a developing country. However, against a Soviet-style air defense system with its redundant high-altitude missile air defense system, aircraft would have to fly low to evade enemy defense systems. Here on the lower right, you can see an Iraqi Shilka ZSU-23-4 23mm self-propelled anti-aircraft artillery system. On the bottom left, you can see an Iraqi SA-8B Gecko self-propelled surface-to-air missile system. Both of these are tactical, meaning they operate locally around ground units. They're armored so they can follow those forces, and they typically attack low-flying aircraft and helicopters. This is a depiction of a Soviet air defense grid, including altitudes and the radius coverage and its distance from the front battlefield. The SA-6 would be up front, the SA-4 Gan-F would be near the front, and the SA-2 guideline would be in the rear. A contemporary Soviet air defense cover is similar, but rather than having cylinders, you would have hemispheres. This is an SA-3 battalion, complete with command vehicles, radar vehicles, missile systems, and a variety of other systems that would support this dispersed system. One radar could be destroyed by an anti-radiation missile, but then another radar vehicle would take over in just a few seconds. This is another Cold War system. This is the Gan-F. Again, it's armored because it operates near the front. This is an SA-5 battalion. These are still in use in North Korea. Here is another Russian system, which also has its origins during the Cold War. The fourth mission is the transport mission, and this involves the ferrying of friendly troops, equipment, and supplies. For example, during the U.S.-Iraq Gulf War of 1990 and 1991, 15,000 flights of U.S. aircraft delivered 600,000 soldiers, which is 65% of the total personnel deployed to the Gulf, and 590,000 tons of cargo, which is 20% of the total, the remainder coming by ship. On the bottom left, you can see a U.S. C-5 Galaxy aircraft, which were enormous aircraft used for strategic airlift. And on the bottom right, you can see a German Air Force C-130's Hercules theater transport, and these aircraft are very good at using short runways near the front of the battlefield. Loss rates. Most air forces suffer between 1 to 3% losses annually due to accidents, depending to a large extent on pilot training, aircraft reliability, the quality of maintenance, and the toughness of training. In some years, India has suffered 5% attrition loss in training, but this is mostly due to poor maintenance. Loss rates in wartime are calculated as losses per 1,000 sorties. So we can make a calculation of daily loss rates for aircraft. This calculation comes from Dunnigan's text, How to Make War, one of the earlier editions. So you have a base attrition rate of 5 per 1,000. If you have an airborne early warning coordination, which is against your friendly aircraft, then this increases by plus 15 per 1,000. If it's a constrained air battle area, like over the Taiwan Strait or Korea or over central Germany, or over Israel, you have a plus 5 loss rate per 1,000. If you're engaging in close air support, there's another plus 5 loss rate per 1,000. If you're engaging in interdiction strikes, which means deep strike against enemy targets, you have a plus 2.5 per 1,000 attrition rate increase. If you're using a standoff weapon, it's a minus 5 per 1,000. But the problem with standoff weapons is, although they're just as accurate, by being far away from a target, you cannot engage in close air support. And if you have a light target, like infantry hiding in a jungle, you may not be able to see the target at all. In a high threat environment, you have a plus 10 loss rate per 1,000. Where a high threat environment is defined as an environment where the ratio of the friendly to enemy is 1 to 2. In other words, the enemy force outnumbers friendly aircraft 2 to 1. If it's a medium threat environment, which means you have a parity between friendly and enemy forces, it's a +5 loss rate per 1,000. And if it's a low threat environment where friendly forces outnumber enemy forces 2 to 1, then it's a +2.5 per 1,000 loss rate. These are some of the historical attrition rates in air operations from the Second World War, Korea, Vietnam, the Indo-Pakistan War, and the various Arab-Israeli wars. And you can see that India and Pakistan had a lot of very aggressive flying. In the fighting over Germany, you're looking at about 900, and that's also very high. And if you look at the Arab-Israeli War, 1973, when it came to the A4 operating against Syrian air defense flak, you had very high attrition rate as well. Now there's some essential points and issues of air warfare. The first is aircraft that can perform multiple missions, such as air superiority and strike missions, are very expensive, and they're actually not optimized for either mission. Here you can see a multi-role aircraft with all the different kinds of air-to-air and air-to-ground ordnance that the aircraft can deploy. So here we have a tactical air mission assignment curve, and what we're looking at the bottom is the ratio of forces, which is the number of friendly to enemy aircraft in a particular area. And we have the percentage of aircraft per type of mission in each of these. So if you were going to conduct an attack against an enemy force, and you had a parity of, say, 1.0, which you can see in the horizontal line at the bottom, then typically you would read from the vertical line above that. You would have air superiority missions accounting for about 20% of the total aircraft. And you'd have about the same number of interdiction and close air support aircraft, each around 40%. When you have a ratio of forces of 2.5, which means you heavily outnumber the enemy air force, and you can see the 2.5 on the extreme right of the horizontal line, then maybe 5% of your aircraft will be air superiority missions, 20% will be interdiction, and between 60 and 80% will be close air support. The second issue is pilot skill matters. It was estimated that if trained and active fighter pilots, only some 20% were aggressively seeking combat, 60% on average, and that about 20% of pilots were not actually useful. The U.S. 8th Air Force during the Second World War recorded the outcome of 5,000 fighter pilots that flew against Germany. And this study indicated that 261 pilots, that's 5.2% of all the pilots that flew against Germany, killed at least 5 enemy aircraft. And this 5.2%, or 261 pilots, accounted for fully 40% of all of the 5,284 German aircraft that were destroyed. In other words, a very small part of the body of pilots kill almost half of all the enemy. 5% of pilots kill 40% of the enemy. Another 1,031 U.S. pilots killed between half to 1 kill. Now, what is a half a kill? A half a kill is when 2 aircraft together partially damage an aircraft. And that the remaining 3,700 pilots killed no one at all. Now, these are statistics that are consistent across many different wars. Now, there are many methodological issues, such as luck, opportunity, and the fact that some pilots are better at assisting or setting up a kill, while others are better at completing that kill. Now, let's take a look at other periods of history to see the same phenomena at play. In World War I, 5% of the pilots accounted for more than 50% of all the victories. During World War II, 5% of pilots accounted for 40% of all victories in the West, and 1% of pilots shot down 46% of all aircraft for the entire European theater, not only Germany. The top 100 German Luftwaffe aces shot down 15,000 aircraft. In Korea, 5% of the 800 U.S. pilots accounted for 37% of total kills. Similarly, 50 Soviet pilots flying secretly for the North Koreans scored over 5 kills each, accounting for 410 UN aircraft lost out of the total of 971 lost during the entire conflict. Of the USSR's 15,000 aircraft in June 1941, at the beginning of the German invasion of the Soviet Union, 1,489 were destroyed on the ground and 322 in aerial combat on the first day, at the cost of 2 German aircraft. By the end of the week, 4,990 Soviet aircraft were destroyed for a German loss of 179 aircraft. During Korea, the U.S. lost 58 Sabre fighters to 818 Soviet MiGs flown by the North Koreans, the Russians, and the Chinese for a 14-to-1 kill ratio. Between 1964 and 1968 in Vietnam, 118 MiGs were destroyed for 56 U.S. aircraft, with the AIM-7 and AIM-9 air-to-air missile hitting just 10% of the time. In 1967, the Israelis destroyed 393 Arab aircraft, of which 58 were destroyed in air-to-air combat, for the loss of 26 aircraft. Most of the Israeli aircraft were lost to ground fire. In the first 30 minutes of the 1973 air war, Israel lost 10 aircraft, and this rose to 40 destroyed and 60 damaged in the first few hours. The Arabs fired 1,500 surface-to-air missiles, hitting only 1.5% of the time. In dogfights, the Israelis still dominated in 1973 with a 1-to-25 ratio. By the end of the war of 1973, Israel claimed 334 air-to-air kills, of which 60 were to cannon fire and 274 to air-to-air missiles, and 180 to ground fire. The Arabs agreed to only 440 aircraft lost. Israel lost 103 aircraft, 40 to SA-2, SA-3 surface-to-air missiles, 40 to the ZSU-23 AAA, of which I showed you a picture earlier on, 10 to the SA-6 surface-to-air missile, 4 to the SA-7 man-portable surface-to-air missile, and 3 were lost in air-to-air combat, although the Arabs claimed 20. In 1967, 100% of air-to-air kills were by cannon. In 1967 to 1973, it was 30% missile and 70% cannon, and in 1973, it was 70% missile and 30% cannon. In 1982, Syria lost 50 of its 200 aircraft in just 3 days. Ultimately, 85 were destroyed. 40 were lost to Israeli F-15s, 44 to Israeli F-16s, and 1 to an Israeli F-4. In the Falklands War, British Harrier aircraft shot down 32 Argentinian aircraft, 19 by AIM-9L air-to-air missiles and 6 with cannon, for no loss, although 3 Harriers were destroyed by ground fire. 26 AIM-9 air-to-air missiles were fired in 23 engagements, destroying 19 targets in the Falklands War. In the 1991 Iraq-US War, 32 Iraqi aircraft were destroyed, 30 by American and Saudi F-15s, including 2 to Saudi F-15s and 2 to F-18s. 80% of kills occur in the 6 o'clock. In other words, aircraft that get shot down are killed by an aircraft directly behind them, even with modern missile warfare. So let's take a look at some of the top Second World War aces. For the British, we have Group Captain J.E. Johnson, who had 38 enemy aircraft killed. One of the top British aces actually had no legs because of an aerial accident, and peculiarly, this kept the blood draining from his head into his legs, which allowed him to make tighter turns than most other pilots. You've got Saburo Sakai of Japan, who shot down 64 aircraft, and he has a book where he goes into great detail in how he performed in the Pacific. The top ace is Major Eric Hartmann, who shot down 352 enemy aircraft, mostly on the Eastern Front against the Soviet Union. Pilot selection matters because, in modern terms, they're very expensive to train. They cost about $250,000 to train an engineering officer, but about $5 to $10 million to train aircraft pilots. Here you can see a picture of Saburo Sakai. One of the strangest stories about selecting a fighter ace is the story of Gabe Gabreski, a Polish-American who did not perform very well academically in the lead up to World War II, But when Germany invaded and occupied Poland, he signed up. And he got his pilot's license just barely. The instructor felt sorry for him and normally would have failed him, but Gabe Gabreski was trying to get into the U.S. Air Force to prepare for war. So he was given a pass when he shouldn't have been given a pass. He was not fit to fly. So Gabe Gabreski tried to join the U.S. Air Force, which failed, and at that time U.S. Army Air Force. And so he went to England and joined the Polish squadron flying within the Royal Air Force and participated for more than a year flying aircraft in England. He was decidedly a poor pilot. Not only did he perform poorly in air-to-air operations, but there was a camera on his aircraft, and there was one particular instance where the aircraft was directly in front of him for quite a few moments, and he didn't even ever recall the aircraft was there. So he performed very badly. After Pearl Harbor, the U.S. entered the Second World War, and so he transferred over to an American unit. And again, he was a very poor pilot. He was known for damaging aircraft while landing. So not someone you'd associate with performance. So while he was in his third, going on his fourth year flying in Europe, something happened. Something clicked. Normally, you determine if someone can fly an aircraft, within the first 1 month of their training program. And if you determine they're not competent, you shift them out of maybe piloting into flying transport aircraft. And if they can't even fly transport aircraft, you move into some sort of administrative function, not involving flying machines in the sky. But Gabe Gabreski was taking advantage of the desperation for pilots. And the lifespan of a pilot during the Battle of Britain was very short. You have young men, 19, 20, 21, who survived only for a few weeks in the very high attrition environment. So he survived. So in 1944, Gabe Gabreski flies out and shoots down his first aircraft. And then he does the same thing in the next few days. And again, and again. And he goes from someone who can't fly aircraft to someone who suddenly understands how to shoot down enemy aircraft. And he shoots down so many aircraft, German aircraft in Europe, that he gets up to 34.5, which makes him the top American ace in the European theater during the Second World War. On the last day of his tour in his American unit, he was scheduled to go back to the U.S. to marry his sweetheart. He took his aircraft up without authorization and flew it into Germany. And normally when you approach an airfield, you're supposed to fly and attack it once. If you fly and attack it a second time, the AAA, the anti-aircraft artillery there, will then know you're coming and have a much higher chance of shooting you down. So he flew over the airfield, alerting the Germans that he was coming. Then he turned around to attack the airfield. So the anti-aircraft artillery was shooting at his aircraft, which was not supposed to be flown by him. And so he flew lower and lower and lower to avoid the incoming flak, and he snapped off his propeller on the ground. And his aircraft leisurely landed at the German airfield, and he was taken prisoner. And he remained a prisoner of war until the war ended, at which point he was able to rejoin his fiancée and get married. His lack of good piloting skills, particularly the damage he inflicted on aircraft when landing, meant that he couldn't get a job as a civilian airline pilot after the war. So he remained in the Air Force. When the Korean War came along, he again became an ace. And he served in the U.S. Air Force until 1967, being one of only a few pilots that achieved ace status both in the Second World War and the Korean War. The methodological issue is this. The U.S.'s best fighter ace can't fly airplanes well. And he came to fruition only after many years of operation. Therefore, how do we select pilots? They are rare, very often eccentric gems. Canada's leading fighter of the Second World War was a Swedish-Canadian by the name of Buzz Burling, who flew aircraft from Malta. He had certain personality issues that made him very combative with his superiors, and he refused to fly in formation. So his primary way of flying was alone, and he would go out and hunt for German aircraft. So he was not a team player. He was ultimately killed in a crash in Israel. So there's a lot of methodological issues on how you select these incredibly important, incredibly well-skilled, rare individuals. Now, pilot skill matters, and to a great extent depends on the annual flying hours that is available for the pilots to train. However, it's very expensive to train up to 200 hours per year, as it wears out the aircraft. The U.S. Air Force typically has 205 hours for a fighter pilot per year, 186 hours for a bomber pilot, 218 hours for tanker pilots, and 288 hours for transport pilots. The Israeli Air Force, which has a high standard of preparation, has 180 hours for its regular pilots and 80 hours for its reserve pilots. For Iraq, before the U.S. invaded in 2003, they averaged about 90 to 120 hours for their senior pilots and only 20 hours for their junior pilots. For Russia in the 1990s, when there was a significant problem with funding, tactical and air defense pilots flew only 15 hours a year and 25 hours if they were flying long-range aviation. That has changed in the 2000s. Now, very importantly, unrested pilots suffer steep losses in performance. So it's very important that pilots receive good rest. Here you can see Japanese and U.S. comparative training hours during the Second World War. And it's associated with battles. And the obvious consequence is that the Japanese were highly attrited by U.S. pilots that received far more training. So these are U.S. 8th Air Force aces in World War II, and the distribution of kills achieved by the number of pilots. This is the same analysis showing the percentage of pilots and the number of kills they inflicted. And again, you see the same issue over and over again, which is a very small number of pilots do a disproportionate amount of the shooting down of enemy aircraft. Issue number 3. The skill of the ground maintenance crew has an enormous impact on the ability to use aircraft. Those that maintain the aircraft need to be technically well trained, especially in the age of modern combat aircraft. Poor training or the absence of these personnel because of casualties inflicted by attacks on air bases can have serious consequences for the sortie rate of the aircraft. The sortie rate is how often an aircraft can take off in a given amount of time, often measured in days or a week. Aircraft need continuous maintenance, part replacements, and alignment because of the high stress on the airframe and because of the enormous heat of the engine, let alone damage inflicted on the aircraft from missiles blowing up nearby and putting shrapnel in the aircraft, or bullets coming from anti-aircraft artillery and passing through the airframe. For example, it takes 40 hours of maintenance for every hour that the Russian Sukhoi 27 flanker is flying. So that could be one person working for 40 hours, or 10 people each working for 4 hours. A US F-14 took 23 hours, or 25 hours, for every 1 hour of flight. The sortie rate varies anywhere from once every 48 hours for a typical developing country Air Force to about 4 to 5 times per day for an extremely well-trained maintenance crew. The problem is you can always do less maintenance, but then you have a significant increase in spontaneous failures of the aircraft. An Iranian F-14A Tomcat, which is an aircraft that Iran bought from the US, but still operate since the Iranian Revolution, lost a lot of their technical ground crew. And so they were only able to maintain a sortie rate of about once per week. Here you can see a Soviet-era MiG-23 Flogger fighter aircraft undergoing maintenance. Now, some aircraft have very limited endurance. In other words, you have to do a major overhaul of the engine every several hours. So an F-86 American fighter from the 1950s needed its engine replaced after 300 hours of flight. An F-4 was more durable. Its engine had to be replaced every 1,000 hours. An F-16 every 4,000 hours. An F-15 every 8,000 hours. A fourth issue is the importance of surveillance. AWACS is the most valuable aircraft type because it permits seeing enemy aircraft over great distances, which cannot be done as well with ground-based radar, even if the ground-based radar are located on top of a mountain. Such as in Nicaragua, the Sandinista regime had a radar on top of their volcano at Masaya near their capital, Managua. AWACS aircraft can also help coordinate the interception against enemy aircraft. It used to be that a very small number of aircraft had these systems, but more and more aircraft are purchasing them, and they're essentially required for countries that have large air forces. The U.S. has 78 E-2Cs, which are operated by the Navy, and 33 E-3s, of which 17 were deployed in Luxembourg during the Cold War, but are now much more broadly distributed. The E-3 is considered to be the top of the line as far as surveillance aircraft goes. Japan had 10 E-2Cs and 4 E-767s, which are the equivalent to the American system. The Russians had at one point 16 A-50s, but these were significantly degraded with the end of the Cold War. Taiwan has 4 E-2Ts, which are similar to the US E-2C system. And then you have other countries that have systems like Israel, Egypt, Singapore, Sweden, India, Spain, France, the United Kingdom. Mainland China has an increasingly large AWACS force, numbering close to 20 at this point. And their ally Pakistan was provided a tailor-made system by the Chinese. Iran has one Ilyushin 76 airborne early warning built by the Soviets for the Iraqis that defected during the US-Iraq War in 1991. You can see here a control center in an E-3A. So you can see the top-of-the-line AWACS aircraft even today, which is the E-3, which is in the top left. You can see a Royal Navy helicopter, a Sea King airborne early warning aircraft with the radar underneath it, immediately below the picture of that aircraft. At the bottom left, you have a Japanese E-2C. You can see the radome on top of that aircraft. On the right, on the top, you have a Soviet A-50 mainstay, which is their standard airborne early warning aircraft. It's an Ilyushin 76 airframe with the radar on top. Beneath it is the original Soviet airborne early warning system, which was the Tupolev 126 MOS. And at the bottom right is the French S-2 Tracker, which is a very small aircraft designed to conveniently deploy on older French carriers, and this enabled inexpensive surveillance. Now there are disputes in doctrine in air warfare. Dispute number one is, do you shoot down enemy aircraft by doing a surprise attack, or do you train soldiers to dogfight? In other words, to do violent close-in maneuvers to get behind an enemy to shoot them down. Surprise emphasizes using ambush tactics and aircraft speed and coming out of the clouds or coming out of the sun so that the pilot you're attacking is blinded, or attacking aircraft from the rear before they can see you and react. Dogfighting focuses on maneuverability and turning very tightly at close range, which is difficult because the G-forces aircraft can perform are beyond what the human body can resist, and people suffer blackouts where the blood drains from the head into the feet and they lose consciousness. Now, surprise is extremely important in air combat, dating back to the First World War, and it explains 80% of the aircraft that were shot down. And of those that were shot down, they were typically shot down within 90 seconds. Dogfighting was generally avoided because it was seen as dangerous and basically producing random outcomes. Lieutenant Colonel Mark Hubbard, commander of the 20th Fighter Group, for a short period of time, estimated that 90% of all fighters shot down never saw the guy who hit them. Now, the doctrinal preference of surprise over dogfighting affected aircraft design. The U.S. focused on high-speed and low maneuverability aircraft, which did not actually prove very useful for multi-role missions, especially ground support missions where you have to do tight turns to avoid anti-aircraft fire or mountains. So here you see an F-104 Starfighter in service with the West German Air Force, and this was one of those typical kind of aircraft. A very fast interceptor, very small wing surface, powerful engines, but not good at maneuvering. Now, surprise tactics were also not very useful against targets that stayed close to the ground, meaning aircraft flying very close to the ground. And in both the Korean and Vietnam Wars, U.S. pilots, particularly the U.S. Air Force, had to be retrained to dogfight. And only after that retraining were the U.S. able to improve their kill ratio between Vietnamese and U.S. Air Force aircraft being shot down. This chart shows the weapons used by different U.S. aircraft, which are listed on the left side, against targets flown by the Vietnamese Air Force on the right side. Now, the second doctrinal dispute in tactical air operations is the trade-off between interdiction bombing versus close air support bombing. Now, the Air Force of most countries, but particularly the U.S., believe that with precision weapons they can win tactical wars without even needing ground forces. Consequently, they prefer interdiction missions, which means to strike deep into enemy territory, rather than providing close air support missions to ground soldiers on the battlefield. Now, the U.S. Marines have a different philosophy, and they train their pilots to perform a high quality of close air support. And that's why the U.S. Marine Corps have their own air arm. This is from the manual. Quote, "It is possible that aerospace forces can make the most effective contribution when they are employed in parallel or relatively independent aerospace operations." This is what the U.S. Air Force claims. Quote, "Although close air support is the least efficient application of aerospace forces, at times it may be the most critical by ensuring the success or survival of surface forces." Close quote. So there's a big dispute where the Air Force wants to get rid of the A-10 Thunderbolt close air support aircraft and replace it with the F-35 doing long-range precision-guided weapons, and the U.S. Army, decade after decade, then offers to take the aircraft from the Air Force, and then the Air Force is compelled to retain the aircraft. My general interpretation is that close air support is vital and has a huge force multiplier, and interdiction is exaggerated. This is a picture of a Royal Air Force Jaguar bomber. So the future of air forces, which is one of the issues that's emerging, is the push into outer space, from air power to aerospace power. The shift from human-piloted to robotic or autonomous aircraft, and the shift to ultra-fast hypersonic reconnaissance aircraft like the Aurora, which may or may not have existed. So let's take a look now at the case of the Battle of Britain in July and October of 1940. This was the first decisive battle fought entirely in the air, and thus permits us to control for other factors to see a distilled impact of the principles of war on tactical air warfare. In July 1940, a month after the fall of France, when it appeared to Hitler that the British would not agree to a ceasefire, Hitler gave orders to the German Air Force, the Luftwaffe, to destroy the British Royal Air Force. This would make it possible to keep the British Royal Navy from interfering with German Army's amphibious conquest of England, codenamed Operation Sea Lion. This would involve the initial landing of 10 German infantry divisions and 1 airborne division in September of 1940, followed by a heavier follow-on force of 17 divisions, including armored forces. The attack would have to go in September earlier, due to the rough seas of the English Channel and the North Sea. You can see a picture on the left of a blasted intersection in London resulting from the war, and on the right, Germans practicing amphibious landing from a landing craft. This is a map of the planned German amphibious invasion of England and its subsequent push to London. And what's key here is the concentration of the landing force from different ports on the French coast. So what were the German forces and plans? The Germans had deployed Luftflotten 5, or Air Fleet, in Norway and Denmark, Luftflotten 2 in Belgium, and Luftwaffen 3 in France, with a total of 3,500 aircraft, of which only 60% were serviceable at the conclusion of the German invasion of France. And these included 1,102 bombers and 1,025 fighters, of which included 656 were high-performance Me-109s and Me-110s, although the Me-110s were less effective than the Me-109s. The range of German and British fighters were both about 125 miles. But since the fighting would take place over England, the German fighters would have a shorter loiter time before they had to return. As well, when aircraft were shot down, there was a 50% chance that the pilots would survive. British pilots were typically reunited with their squadrons and flew again because they were either shot down over England or the Channel, where the British had light ships to pick them up. Whereas German pilots parachuting down over England typically became prisoners. Here you can see German Air Marshal Hermann Goering. The best German bomber was the Junkers Ju-88. The Junkers Ju-87B Stuka dive bomber was very vulnerable due to its slow speed. The German Heinkel 111 and the Dornier Do-17Z and Dornier 217 were also somewhat slow and vulnerable. Here you can see the different Luftwaffe bombers. On the top is the Dornier Do-17E bomber. In the middle is the Heinkel HE-111 bomber. And the bottom is the high-quality Junkers Ju-88 bomber. The top picture is of the Junkers Ju-88 bomber, and the bottom picture is the very vulnerable Ju-87 dive bomber, which is so useful in tactical warfare, but not so useful in interdiction combat because of its slow speed. The top picture is of the German Luftwaffe Messerschmitt Me-109 fighter, which was the main high-performance fighter at the beginning of the Second World War for the Germans. And you can see in the bottom, the most common British fighter was the British Hawker Hurricane. Now, German pilots were more experienced than the British, having fought over Poland in 1939 and France in 1940. The Germans estimated it would take 2 to 4 weeks to attrit the Royal Air Force into ineffectiveness, and then they could begin their amphibious operations. However, the Germans had little intelligence on British capabilities, tactics, or strategies. Here you can see German pilots. Here you can see a map of the different air areas and the different squadron locations and air bases in Germany and England. On the right, you can see a German bomber dropping explosives, and on the left, you can see the missions given to Luftflotte 2, Luftflotte 3, and Luftflotte 5, and the individual air bases in Fighter Command Group 11, which is where London is located, Fighter Group Command 10 Group, which is located in Dorset, Fighter Command Group 12, which was protecting the air bases around London, of Fighter Command Group 11 Group, and then Fighter Command 13 Group, which was in the north. So, British forces and plans. The British had just 609 fighters, of which 87% or 531 were serviceable because of the attrition suffered in the battle over France. These aircraft were organized into 12-plane squadrons, armed with the comparable Supermarine Spitfire, which was a sports aircraft designed in the 1930s, and the less capable Hawker Hurricane. In July 1940, the German Luftwaffe outnumbered the Royal Air Force in terms of bombers and the escorts 3-1. However, British aircraft production was twice that of Germany in the early months, because the British made it a priority. Fighter Command's number 11 group had 15 squadrons of Hurricanes, 7 of the high-performance Spitfires, and 2 of Blenheim fighter bombers. And these were deployed at airfields south of London. And number 12 fighter group was in direct support and deployed north of London. 12th group was used to protect 11 group's airfields, while 11 group was engaged against the Germans. Because if you recall, airfields are very vulnerable. And thus, 12 group was not available to make interceptions of German aircraft and help achieve a concentration of force. On the top picture, you can see Royal Air Force Air Marshal Hugh Dowding, who was later recognized as the mastermind of the British campaign. Below him is British Prime Minister Winston Churchill, who depended on this victory to keep the British independent. These are the Royal Air Force Hawker Hurricane aircraft, which were the mainstay of the battle, but were slow compared to the German aircraft. This is the Supermarine Spitfire, which was the top aircraft of the Royal Air Force. It was a very easy to handle, very fast airplane. And you can also see in the bottom right a German bomber sinking into the English Channel. Now, the British were able to achieve surveillance superiority over the Germans because of their investment in radar. The British developed the Chain Home, CH, radar that focused on aircraft flying below 15,000 feet, although the system could not see well above 20,000 feet. There was a second series of radars, the Chain Home Low, which detected aircraft down to 2,500 feet. Now, it was difficult to estimate the number of bombers in a formation, and it took 4 minutes to scramble a squadron from the point of detection, and 13 minutes for the fighters to climb to the 20,000 feet to make the interception, because that's the typical altitude of incoming bombers. Nevertheless, these radars permitted effective interception of German formations. The British had also broken the German Enigma code, permitting access to the broad outlines of German strategies, but not the specific operational plans of the German Luftwaffe. Thus, the total British force, including pilots, ground crews, the observer corps, and the air defense troops, and radar operators, totaled about 100,000. So these consisted of underground bunkers, observers in towers who had binoculars and a telephone, and all those that manned the air defense cannons, the balloons, and the searchlights. British Air Marshal Hugh Dowding planned to feed the aircraft in slowly in order to keep them from being tied down, because it was very difficult to disengage aircraft once they were caught in air-to-air combat. To turn around meant that the enemy would chase you and shoot you down. And he also didn't want Germans bypassing aircraft and then to destroy the aircraft bases. He therefore always kept an air reserve. In this picture you can see a Hawker Hurricane. So this is a picture of a radar system, specifically the Chain Home. You can see the coverage in the map on the right, the low coverage and the high coverage of incoming aircraft. Arthur C. Clarke is a science fiction writer associated with the movie 2001. And he was a young operator of one of these radars. And what he did, which was unauthorized, was he aimed his radar at the moon, and the signal bounced back. And it occurred to him that artificial satellites would facilitate communication. So he was one of the first to discover this interesting possibility. Here you have the Chain Home radar system on the cliffs of Dover in the United Kingdom. Here they are again. Here you can see British pilots waiting to scramble and then actually scrambling to their Hawker Hurricane aircraft. And you can see a British command and control center which helped coordinate the interception of the Luftwaffe aircraft. So phase 1 of the campaign, the Kanalkampf, or the Channel Battle. From July 10th to August 13th, 1940, German aircraft raided the British coast to draw the fighters into battle by mainly targeting British merchant vessels and port facilities. The Germans gradually established daytime air superiority over Dover. Now, the British permitted the loss of many ships in the Channel, but did not commit to battle. This preserved the British ability to retain maneuver and the initiative. The British fleet itself had located far to the north, out of range of German aircraft. German losses were 180 aircraft, but the Germans were producing 800 pilots a month. British losses were 70 aircraft, but the British produced 496 new fighters in July. By the end of August, the British inventory of aircraft had gone up to 1,081 fighters and another 500 undergoing repairs. The overall evaluation is that the British avoided German attrition, but at considerable loss in coastal shipping. Phase 2 went from August 13, 1940 to September 7th. Starting with an attack on August 13th, the Altertag, Tag, or Eagle Day, the Germans attacked British fighter and radar bases in the daytime with 1,486 aircraft, followed by nighttime raids against British fighter factories, which were very successful. The Germans used diversionary raids, this is a part of the principle of the economy of force, to distract British fighter units and dilute the British concentration of force. The British had trouble achieving a concentration of force because of the risk of committing their air units that would then be bypassed, and then the bases would be destroyed, which would have led to a wide dispersal of British aircraft at farther airfields. It also took too long for the British to assemble large forces for interception. And this actually comes out of the memoirs of Albert Kesselring, who was a German Luftwaffe general. So there's a problem here of target fixation, which was more of a problem than simply environmental awareness. The German battle damage assessment was actually quite poor. In other words, the Germans didn't do a lot of reconnaissance after they hit targets, and the Germans had wrongly assumed that they destroyed 8 air bases on August 13th. They also exaggerated the losses inflicted on the British Royal Air Force. They thought the British had lost 574 aircraft shot down and 200 aircraft destroyed on the ground, thus leaving the English only 430 aircraft, of which 300 were estimated to be serviceable. In reality, the British had some 650 aircraft remaining. And this is the result of the absence of German reconnaissance. Here you can see German bombers flying over England. In Phase 2, continuing, the consequence was that the Germans stopped attacking the British radars, so they could instead concentrate on attacking the British fighters in the air. There were large attacks of 1,786 aircraft on August 15th and 1,700 aircraft on August 16th against air bases, with a further 33 large attacks between August 29th and September 7th, severely damaging 5 British airfields and reducing the ability of the British to protect their air bases. By the beginning of September, the British had lost air superiority over its southern coasts and were beginning to lose generally in the War of Attrition. But the Germans did not recognize that the British were near catastrophic failure because of the poor staff work and bad intelligence analysis. The Germans at this point had lost 450 aircraft. British losses were 359 aircraft, which was at this point greater than their monthly air production rate. And 25% of their pilots were lost. So reducing their number of pilots from 1,434 to 1,023, including 80% of the squadron leaders. In other words, the British were losing most of their leaders in the air. New pilots had only 10 hours of flying experience, and training had been reduced from 6 months to 2 weeks. The general evaluation is that the Germans stopped attacking the radars when the British were beginning to lose their advantage. You can see in the picture a collapse of a building in London. Phase 3, from September 7th to September 15th, was a critical 1-week period. The Germans, due to poor staff work, did not realize how weak the British had become in early September and therefore became more risk-prone to draw British fighters into an air battle. the Germans shifted from hitting vulnerable airfields to instead attacking civilian targets in London. This was also partially influenced by a British bomber attack on Berlin, the German capital, on August 25th. This led to a furor against the Nazi Party, and Hitler harangued on the radio that he would get revenge. Starting on September 7th, 1940, with 372 bombers and 642 fighters, the Germans attacked docks, oil facilities, and factories in London. British Air Force resources were pushed to their limit, and all reserves were committed for the first time. But this allowed the British airfields to be rebuilt. The main problem was that by shifting north to do battle over London, the German fighters had less loiter time than they did when they were attacking southern England. And this facilitated their interception, as both number 11 and number 12 fighter group were more closely located to the locus of the battle, which is London. On September 15th, the Germans conducted a large 1,000 plane raid on London, whose scale and depth permitted the British to deploy multi-squadron formations to conduct concentration of force interceptions. And the result was the infliction of heavy losses on the Germans. It was this engagement that was the turning point in the Battle of Britain. The result was that the balance of attrition shifted back to the British advantage, and the British began air operations against German forces assembling in France for the invasion. In other words, the British were hitting shipping and ground concentrations in the French ports. On September 18th, the Germans postponed Operation Sea Lion until the spring of 1941. Here you can see a picture of German bombers in rows. This here is a British and German aircraft losses chart, and you can see generally the Air Force lost less aircraft than the Luftwaffe. Phase 4 was the Blitz. With the main purpose of the German operation unfulfilled, which was the destruction of the British Royal Air Force, the German Luftwaffe shifted to nighttime bombing of Britain's industrial area, with an average of 250 bombers striking each night. And these cities included Coventry, Birmingham, Bristol, Liverpool, Southampton, Glasgow, Leeds, Manchester, Plymouth, and Sheffield. Attacks declined sharply by the end of 1940. This is a picture of London burning. The London Tube, or subway, was used as a bomb shelter. This chart shows the German bomb tonnage dropped on Britain between August of 1940 and February of 1941. Here you can see a London two-decker bus parked in a hole in the middle of the street. Overall evaluation. The German losses were 1,294 aircraft, although the British claimed 2,698. British losses were 788 aircraft, and the Germans wrongly believed that to be 3,058 aircraft. The Germans were defeated because they were hampered by poor reconnaissance. With good reconnaissance, they would have recognized how the British radars were key to providing the British the initiative and the freedom to maneuver. And the Germans could thereafter have been able to destroy the radars and then move on to destroy the vulnerable British air bases and keep the British from counter-concentrating against German operations. Here you can see a damaged part of a London street.